Hi guys, this is from Module 4.2, Transversals and Parallel Lines. Our essential question is how can you prove and use theorems about angles formed by transversals that intersect parallel lines? So first things first, um, theorems, that's kind of a new thing, right? Kind of. Angles, we've talked about angles, right? Like angle 1, for example. We talked about that. Transversals, what is that? What? That's a new word. That's a new word. Okay. That intersect parallel lines. Okay, we've seen parallel before, right? Like in algebra 1, we've seen parallel lines that never intersect, right? Especially with systems. And then you would say what? No solution. So we've seen that before. So our shortest answer for proving theorems about angles formed by transversals that intersect parallel lines is basically we have to establish a postulate regarding pairs of angles. Okay, for example, we can form something about vertical angles, right? Like if this was angle 1 and this was angle 3, and angle 1 was 60 degrees, well, we would know that angle 3 is also 60 degrees, and that's because they are vertical angles. So it's a lot of that concept. Like there's a relationship between certain angles, and we can start trying to make sense about solving for other angles in a situation. So that's one of the angles that we've dealt with before. Now we're dealing with same side interior angles, and we're going to get to some more later, okay? So these postulates, they basically just allow us to prove a theorem or a problem. So sometimes it's just proving it, other times it's actually real world application. All right, so focus on the postulates. Those are the ideas. Okay, then use them to solve. So if you don't know the postulates, then you don't know the ideas, and then how are you going to know how to even apply them? Okay, and won't let me draw a star. Now I'm sad. All right, so definitions. A transversal is a line that intersects two coplanar lines at two different points. So T, for example, if you look at the little picture there, let me get my highlighter. T would be a transversal. All right, he crosses across two other lines and just hits them at two different points. Okay, so one right there and one right there. All right, and definitely those angles or those lines P and Q are not just visually looking at it, they're not parallel, but we're going to deal with parallel ones. Now, one reason we use transversals in the real world, if you notice the barn fencing or the gate, the transversal comes through here, adding extra support to these boards or planks or um, basically strips of wood or fencing. So we use transversals for support and integrity all the time, especially in engineering. All right, so angles to know, big time. So you have to know these angles, otherwise, it's going to be tough. All right, so first things first, let me draw a transversal going through these two parallel lines. So here's my transversal. What was that? There we go. So here's my transversal. It's cutting through line L and M. All right. We're going to say this is angle, let's see, 1. This is angle 5. This is angle, let's see, 3. This is 6. And 7 exterior. And I guess that would be 8. And 2, 1, 2, 3, 4. Okay, so I'm just numbering all my angles for the situation. So corresponding angles, what are they? Let's find out. So corresponding angles would be an example of angle 1 and 5. So angle 1 and 5 would be transversal or corresponding angles. Now, what you need to know about the relationship between corresponding angles is that angle 1 and angle 5, if you guys look at what I drew there, angle 1 and angle 5 kind of look like they're at the same angle, right? And that's because angle 1 should be congruent to angle 5. And that's based upon, again, corresponding angles. So they're an angle pair, they're corresponding, And if you think about it, they're both facing the same direction, right? They're both on the top left of the intersection of the transversal. You guys notice that? Top left, 1 and 5, okay, for both intersections. All right, so let's look at same side. And same side is literally what it's named after. Same side. So example, angle 3 and 6. Notice how angle 3 and 6 are on the right-hand side of the transversal, but they're also on the inside of the parallel lines. So that's why we call them same side, because they're on the right side. Now it could be on the left side too, like 4 and 5. Those are same side technically. And interior because they're in between the two parallel lines, L and M. So angle 4 and 5 would also be considered same side interior angles, just as 3 and 6. Now, what does this mean in terms of how to apply this? Well, angle 3 and angle 6, whatever angles they are, if you measure them with the protractor, they would actually end up being supplementary. They would both add up to 180 degrees. So angle 4 and 5, for example, since they are same side interior angles as well, they would also add up to 180 degrees because they, again, are supplementary. All right, so highlighter. Let's pick a green. All right, alternate interior angles. So they're basically non-adjacent. That means they're not across from one another. That lie on the opposite side. So key thing there is opposite sides of a transversal between the intersected lines. So a great example would be angle 3 and 5. So highlight there, highlight there. Those would be alternate interior angles. Now, if you actually look at them, the relationship between angle 3 and 5 is that angle 3 is going to be congruent to angle 5. And we'll experience this and we'll practice it and measure things with protractors, and eventually we'll prove you every time. Okay, so these are things just accepted as basic knowledge, and that's why they're considered postulates. All right, so here we go. Alternate exterior angles. So that's the last one. It's not too crucial for, I think it's according to the framework, but I could be wrong sometimes. So let's see, we got, what color? Blue, we haven't used blue. Alternate exterior angles lay on the opposite sides of the transversal and outside the intersecting lines. So angle 1 and 7. If you guys notice, angle 1 is out there on the outside of the parallel lines, and on the alternate side, angle 7's just hanging out on the outside. So they're like the furthest away from each other compared to all the other angles. All right, so that's not too important compared to the other ones. Corresponding angles, same side angles, alternate interior angles, those are really important to definitely know. Alternate exterior angles, just remember they're literally the furthest away from each other on the outside. Angle 2 and angle 8 would be also a great example of alternate exterior angles. Now, even though they're on the very far end, one thing about them, about these alternate exterior angles, is they too are congruent. And we'll get to proofs and examples, especially in your homework, where you have to prove that idea that angle 1 and angle 7 are congruent. All right, so let's get going. So the postulates, these are things not to ignore. So same side interior angle postulate. Basically, it says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. That means that they add up to, so angle 1, or just, two angles that happen to be same side interior angle have to add up to 180 degrees. All right, and I kind of mentioned that earlier. So we already drew or already have these parallel lines with the transversal and numbered the angles from 1 to 8. Wonderful. All right, so let's see. Let's identify the pair of same side interior angles. So again, we have several that we could pick from. Angle 3 and 6 are a pair of same side interior angles. And angle 4 and 5 are also same side interior angles. So angle 4 and 5 should add up to 180 degrees, as including 3 and 6. So angle 3 and 6 should also be supplementary and add up to 180. So identify the pairs of same side interior angles. So angle 4 and angle 5, and angle 3 and angle 6. Now, what does the postulate tell us about the same side interior angles? Basically, that angle 4 plus angle 5 should equal 180 degrees, and angle 3 and angle 6 should also add up to 180 degrees. So, in a situation, this is a lot like your homework right here. If angle 4 happens to be 70 degrees, what is angle 5 going to be? Well, if angle 4 is 70, we'll just substitute that in. All right. And then basically subtraction property, right? So I'll do it over here. How do you get rid of a positive 70 degrees? Because again, we're isolating our variable, which is our angle 5, the unknown quantity. How do you get rid of a positive 70 degrees? Subtract. Now, if you could already do this in your head, good. That means you did a great job in algebra, probably even in middle school, so good for you. I promise it'll be worth it, at least on an individual level. All right, so angle 5, 110 degrees. Voila. Now, explain. Well, we already knew that according to the postulate, these two guys, angle 4 and 5, had to be 180. So if they told us that angle 4 was 70, well, just substitute it in. All right, solve for angle 5. Voila. All right, so your turn number 1 and 2. All right, so explain how you can find angle 3 from the diagram, and then this is the diagram over here, the one we used last slide. Now, they're telling us that P and Q are parallel, and they're basically saying, well, angle 6 is 61 degrees. So that guy right there is 61 degrees. So basically, explain how we can find angle 3. How can we find that guy? So first things first, what kind of angles are angle 3 and 6 in relation to each other? That'd probably be my hint, and I will say no more. All right, so go ahead and try and figure that one out. All right, and again, just explain if you solve for angle measure or the measure of angle 3, that's what that M means right there. It means measure. Okay, measure of angle 3. If you solve for it, that's fine. Just make sure you can explain. That's the important part for geometry. All right, so what if? All right, so what if? So if M and N are parallel, again, that symbol right there means parallel. All right, how many pairs of same side interior angles are shown in the figure? What are the pairs? So again, same side interior angles, look at the definition, and then you should have some kind of response to that. I remember talking about it. So definitely look at your notes, see what same sides are, okay? All right, so postulates continued. Alternate interior angle theorem, that's a really big one. That's really important. We use that throughout the year. You'd be surprised on how often it pops back up. So if two parallel lines are cut by a transversal, then pairs of alternate interior angles have the same measure. So they have the same measure or congruent, right? So just be aware of those two words. So proving alternate interior angle theorem. So we're going to be doing a proof by a table. All right, so this is a table kind of proof. They basically gave us this information that P and Q are parallel. That was given. They gave that to us. How nice of them. All right, and then we're going to use this word bank down here. It's got the 6 reasons or theorems or anything worth mentioning. In college, especially, those things are kind of ingrained in your head after a while. It just becomes a part of your basic knowledge. So that happens. Now, step 2, they basically say, well, angle 3 and 6 are supplementary. So they're talking about this angle here and this angle here. And why are they saying that they're supplementary? Well, first things first, what kind of angles is 3 and 6? I'm thinking same side interior, right? So let's see. But let's see. Same side, they're supplementary. Same side. Yeah, I would say yeah, So same side. Sometimes when you go through the book, you have to try to figure out what the book was saying in context. You don't want to misspeak, and next thing you know, you look at the book going, "Oh, why didn't you just say it this way?" But trying to follow along as best I can in my head about this. So same side interior angle postulate. All right, that's basic. All right, we already know that they're on the same side. They're both on the right hand side, and they're both in between P and Q. Right, line P and Q. So same side interior angle. Now, then they say in step 3 that the measure for angle 3 and the measure for angle 6 should add up to 180 degrees. Well, that's the definition of supplementary angles. Supplementary means 180 degrees, right? They should add up to 180 degrees, right? All right, angle 5 and angle 6 are linear pair. That is true, right? Angle 5 and 6 share the line of Q, right? So that would be the reason of linear pair theorem. Right, that one right there. Because they share the line, right? Angle 5 and 6 are supplementary, and again, I'm trying to make sure I read this right. I think that's just because, again, linear pair theorem. Yeah. And again, reasons could be used more than once, especially in this situation. It's like they're saying the same thing. They're just like, oh, those are linear pairs. Okay. Oh, and they're supplementary. Oh, it's for the same reason. They're linear pair theorem. Okay. Now, angle 5 and angle 6 equals 180 degrees. Once again, we're using the definition of supplementary angles. This is how people argued thousands of years ago. This is how we still do proofs today. There's many ways we do proofs. This is one of the first ways we can do it. All right, so angle 3 and 6 should equal angle 5 and 6. Well, angle 3 and 6 added up to 180, and so did angle 5 and 6, right? Angle 3 and 6 added up to 180, angle 5 and 6, yeah, so 180 is 180, right? So if they both add up to 180, that's the same. So could we say that angle 3 and 5 are the same? Well, let's figure that out. Let's think. Angle 3 and 6 are 180. Angle 5 and 6 are 180. So of course, those guys could be set equal to each other. Let's think. Substitution. What would be a good reason why? First things first. Angle 3 and 5. Angle 6. Oh, I know now. Do you guys notice this? Let me highlight it. Angle 6, the measure for angle 6 is both here, right? So if we subtracted out the measure for angle 6 to both sides, all that's left is going to be the measure of 3, angle 3, and then the measure of angle 5. So that would be so the bottom reason is the subtraction, right? Property of equality. All right, and I think the second to last was substitution property of equality. Substitution property of equality. All right, because they're both 180, by the definition, right? So instead of just putting 180 equals 180, they just put angle 3 plus 6, which is 180, equaling, right? So that's why that substitution right there. Okay, so that's basically your first proof for alternate interior angles and why angle or the measure for angle 3 should be the same as the measure for angle 5. All right, so your turn number 3. This is going back to the original picture here. In the figure, explain why angle 1, 3, 5, and 7 all have the same measure. All right, why? So, what are their relationships to one another? Um, and then again, why does that make them all, um, you know, um, the same or congruent? And I'm trying to figure out where my pen just went. Oh, this is a nightmare. I think I selected yellow on my pen, and oh, there's my pen. Oh, never use. Oh, sweet red. Okay, sorry. It went yellow and I couldn't see it on the background. All right, that was scary. All right, so again, angle 1, highlighter. That's what I wanted. Angle 1, angle 3. Oh, what do you guys see there? What kind of angles is 1 and 3, right? Angle 5 and angle 7. Oh, what's 5 and 7? Oh, what kind of angles are those? Right? And then what are 3 and 5? Whoa, why are they all the same? So explain why they're all the same. Explain. Okay. All right, so proof of corresponding angles. So let's go ahead and get back to my lovely red pen there. All right, corresponding angles. So basically, if two parallel lines are cut by a transversal, then the pairs of corresponding angles have the same measure. Okay, so let's see. We're basically doing a paragraph proof. So instead of a table, we got this nice little paragraph here. How adorable. And they basically say, given that line P and Q are parallel. All right, so if they're parallel, that's usually denoted by these little arrows right here. So if you ever see those, they're basically just saying they're parallel to each other. Okay. Prove that angle 4 and 8 are parallel or the same. I'm sorry, they're the same. So angle 4 and angle 8. Got it. So given the statement, P and Q are parallel. So angle 4 and angle 6, a pair of, let's see, a pair of, so angle 4 and 6. We're talking about angle 4 and 6. So we already did alternate interior angles, right? Well, isn't that what angle 4 and 6 are? So alternate interior uh, angles, right? So using the alternate interior angle theorem, angle 4 should be the same as angle 6. They should be congruent to each other. They should be the same measure. All right, so the measure should be the same. All right, angle 6 and angle 8 are a pair of vertical angles. Aha. So they're saying this. They're saying basically, oh no, I did it again. I made a yellow pen. No. Okay, hold on. Where is it? Where is it? Where is it? No, no. Ugh, this is driving me insane. Highlighter. There we go. There we go. Okay, so angle 6 is here, angle 8 is there, and those are vertical angles. So using the vertical angle theorem, let's go back to my pen and use red. There we go. Okay, so using vertical angle theorem, angle 6, or the measure for angle 6, should be the same as the measure of angle 8. So let's see, using the transitive property perhaps? Because if you think about it, if the measure of angle 4 equals the measure of angle 6, and the measure of angle 6 equals the measure of angle 8, then by the transitive property, the measure for angle 4 should be the same as the measure of angle 8. So it's like, you high five your 4, you just sneeze in your hand, you're super sick, and then all of a sudden you high five your friend 6, right? Now your friend 6 is sick, and then he sneezes and sneezes on his hand, and then he high fives his friend, right? And guess what? Well, you all had the same disease, right? So technically you gave angle 8 or friend 8 the illness through your friend 6. So that's a transitive property. So using the transitive property. Measure 4 should equal 6. So we substitute measure 4 for measure 6, and the result is measure 4 is the same as the measure of angle 8. Voila. So that's the end of that proof. So remember the transitive property. It's very powerful in the sense of logic. All right, that's an R, sorry. So remember that one. That's a good one. You'll see that a lot. All right, so your turn number 4 and 5, use a diagram in example 2. That was this one right here, okay? And explain how you can prove corresponding angles theorem using same side interior angle postulates and a linear pair of angles. So honestly, try to talk each other through that one. Try to write it as best you can, get a general consensus. Probably write this out on a board, like on the board. Just like ask me for a marker and then try to get a general consensus on why. Okay, so you avid kids, if you're listening to this, definitely try to word this in your own way with your group and try to just write up what you guys think. Definitely, I would draw that picture, just kind of give yourself that visual cue because I think 80, 90%, no, I think it's 80% of our population are visual learners. So that's probably going to help a lot of you guys. All right, so here's more of an application aspect. It's basically just plug and play. So they tell you that angle 4 is 36 degrees. Find the measure of 5. So angle 4 is 36 degrees. Find the measure of 5. And then make sure you explain what postulate or postulates, who knows, you used. That's a question mark. Very hideous question mark. Oh, wow, that's the most hideous question mark ever. All right, so example of finding values and angles. Yay, examples. So basically, we know that this measure here and this measure here are, well, they're on the outside and they're on the opposite, right? So what angles are those? Alternate exterior, right? They're on the outside of, the lines A and B, which are parallel. And we are told that these two streets are parallel. That's lovely. And so basically that means that angle, we'll call this angle UTV, should be the same as P angle PRQ. So if they're the same, that means 2x minus 22 should equal x plus 40. So we're just going to isolate the variable and solve for x, just like in algebra. So this isn't really too much of a crucial idea, but you should still remember your basic algebra, get some practice. That way you make sure you don't forget too much. Okay, so addition property, what you do to one side, do the other, right? So x is 22. I don't really care about that. I'm going to plug it back in. So this isn't really my answer. I'm going to plug it in first. So 2x is really 2 times 62 degrees, right? Minus the 22. All right, 2 times 62 is 124. Subtract the 22 degrees there, and you should get 102 degrees. Now, that is the real answer. So that angle for that road, or for that intersection, or for that corner is 102 degrees. Therefore, this guy should be 102 degrees, and that's by, again, the alternate exterior postulate. All right, so last your turn. Go ahead and figure out what angles these guys are, but first things first, what kind of angles are those, right? So are they the same or do they add up to 180 degrees? What do those two angles for those street corners do? what's the relationship between them, right? Set it up correctly, and you should be able to solve for x. Good luck. Work together on this. Don't be alone. Here's your homework. A lot of this is like, oh, if this measures this, then what is this measure? And it's just basically knowing which angle's which, what's the relationship to, and basic algebra. 19 is a more of a proof one, so enjoy that one. Take your time with that. Definitely ask questions and work together. All right. So you guys have a great day, and I hope you have a good one. That one always makes me smile.